So welcome to the Whiteboard Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. Yeah, we do the show here every Friday, 11 o'clock Central European Standard Time, to allow you, the audience, to ask questions about all about data vault, essentially, cloud computing, any data-driven scenarios you want to talk about. And yeah, you can send in questions via chat here in live. You can raise your hand if you want. You can use the Q&A section here in the client. Happy to pick up your question in a live form. I'm not sure if I have the answer, but we'll see. And it's always a good contest here, right? If you receive multiple questions, I would cherry pick. And we also have a form where you can submit your questions. And one of your attendees here, Michael, he sent in a question including pictures, which is awesome, with some little diagrams. It's perfect. And yeah, if there would be no questions at all, we will talk about the cluster here next to me. We did once, at least. All right. So let me just share the question here for Michael, or Michael, I think. There you go. Come in, there it is. Okay, so this is all about modeling invoices. That's actually a yeah. Let's dig into this. So there's a sample invoice here where you have essentially some invoice header with some company for the customer, some information about the customer, or some data about the customer, some data about the selling party, invoice numbers, an invoice date, and then the line item positions, a line item number, a product on the line item, and be aware the same product could be on the same line item multiple times, right? Well, sorry, the same product could be on the same invoice multiple times on multiple line items, because there's quantities, but also unit prices and amounts. And I could sell you the same product for different unit prices. Why? Well, because there's a discount for the first 1,000 products, for like quantities, you get a $5 price, but then for the next 1,000 products, you don't pay $7, maybe $4, and so on, right? So the same product could be on the invoice multiple times. That's important, actually. All right. And so what's the question? The question is here, what is the best way to model this type of invoice data with line items? And the person here looked in the internet, checked out the book, and he found some solutions here. One is essentially and it's a very popular one. I agree. I'll see this not only in the internet. I also see this in the project, where essentially they create a hub for the invoice number because it's a business key, makes all sense in the first place. They have a hub product because it's a business key again. They have descriptive data on the hub invoice and product. For example, product descriptions. You have invoice dates. You have invoice amounts that's the amount essentially from the footer of the invoice, the amount total, the gross total, and so on. Right. That's what we see. And then we have the line item, the link for the line item that connects essentially the invoice hub with the product hub, which is also good. It works because, remember, the product could be on the same invoice multiple times, but that's been accounted for because there's a link line item ID here. So this gives me a unique alternate key for the link, and I can create or calculate a hash key from it that's unique per link entry. So modeling wise, everything looks good. Then there is some satellite attached to it that has the amounts for the line items, essentially, right? So modeling wise, for me, nice, looks good. I would even bet that you will pass what we call the Jetta test. So you would load the data into the target model here, and then try to reconstruct the original delivery from the source, from the target, sorry. Yeah. So you try to reconstruct the delivery, essentially. And that, I assume, would work. So that seems to be a valid model, and you could go for it. But then you check out the book, and in the book we have this example here, where essentially we use. Let me just check. So I didn't check out this example, to be honest. So we have essentially a similar example. So we got what's missing here is the hubs, essentially, right? So there's a customer hub involved because there's a custom hash key here in the link. There's a salesperson involved, so there must be some salesperson hub. Or in your previous example, there would be some, for example, customer hub and product hub, for example. On the link invoice, this link here contains a bit more. It contains also the invoice number as a numeric field, not as a hash value, but just as a number value, right? Numeric value, like clear text, unhashed. This is what we call a dependent child link, or degenerated link, or peg-leg link, or weak link, or pirate link. Those are 5 names, 5 different names for the same entity type. So it's not 5 different entity types I just talked about. It's the same entity type with different names. So it's called dependent child link. It's also similar to what's named here or referred here as a transactional link or non-hystricized link. It's a similar concept in the end. It's not the same, it's similar. And so what we do is we add the numeric value here to the link structure itself. It refers to 2 hubs, and on a link structure, you also have at least 2 satellites attached to this link. One satellite describing the, I'm not sure about the model here. So because there's one more thing. Yeah, I would model it, to be honest, I would with these days, I would model it a bit different, but let's go to this example first, and then I'll show you how I would model this today. So then there's a satellite here describing not, and that's my flaw here, what I look at the moment. This one here has the invoice issue date, and that refers to the header information, right? Because there's only one invoice issue date per invoice. So naturally, this would be added to some form of header. Now, you could add this to the link line item here. Oh wait, sorry. I was wrong, sorry. So this is the link for the header. This is the link for the header, right, correct. So, okay, sorry. So you got salesperson here, which is not the product, the salesperson who sold it, the customer, the invoice numbers, all in here, that's the link. That link is essentially the granularity matches the number of invoices, sorry for that. And then you got the satellite describing the invoice. So this one contains some header information, header data, like the invoice issue date, maybe some other data from the header describing the invoice. And then you got some additional data, some record locator for the invoice, that kind of stuff, some additional data describing the invoice. Now, what's missing here is the line items. How do we model the line items? And now let me model this let me a bit fresh, right? So let's do this on the whiteboard. And I think there's an example, maybe a better example in the book as well. So let's see, can I write? No. All right, 1 second. Okay, battery's down. Yeah, fresh from vacation, all the batteries are down, right? But let's try this. I'm a fast drawer. All right. So what you have is, even with the previous example, we had a link invoice. We had some satellites describing this link with the essentially the header data. There are 2 hubs involved for now. There's a hub customer with the satellite describing the customer, right? And there's a hub salesperson. Satellite describing the salesperson. That's the model more or less from a bit extended model from the previous slide, more or less. The line items you would add then somewhere in a link line items invoice. And this one now would refer on one hand to the product with satellites. It would also refer to, it will also include, just like up here where we had the invoice number as a descriptive attribute. And this is really a transactional or non-hystricized link. That's what it is. You would also have this line item link would then be a dependent child link. Sorry, it's my mess up here. Dependent. So the example from the book really showed a transaction link on a non-historized link. And now the lower link here, the link line item invoice, that's the dependent child link. And this one would include the satellite line item, the data describing the line item, like the discounts, the prices, and so on, the quantities of the product, and so on this link, on this line item. Now, how do we connect this to the invoice? Because this line item refers also to an invoice. Couple of choices. Modeling wise, you could just add the invoice number also to the link line item number. Here you have the line item number, but also maybe the invoice number. But there's nothing against the fact that you could also create a hub for the invoice number. Okay, now it's getting ugly. Which I would prefer in this case, to be honest. All right, you could even argue, what about this non-historized link? But let's think about this. So what is the better model now? All these models would work. My claim is this is also a valid model. What's the better model? Now, the idea is this. Our goal is not to model data, to be honest, right? Our goal here is to create and build an enterprise data warehouse. And for the enterprise data warehouse, we need more than just a nice model, like having hubs linked satellites or dimensions and facts and so on. We need more than just a model. We need a team that builds the enterprise data warehouse. We need the technologies, the servers, the infrastructure and architecture. We need implementation practices. How do we get data from the source all the way down into all the way through the to the enterprise data warehouse into the desired format of the end user, into the dashboard? And for that, there's one step missing here. And that's how can we derive the dimensions and facts later on? And that's the key question. It's not really about modeling data vault here. It's really about delivering information. Because these data sets, you think about this, these data sets here are quite large. And depending on the industry you're in, you might deal with invoices and maybe orders. You might also deal with call records or IoT messages and so on. And then these tables where we model this data as, where we model transactions as non-historized links or dependent child links, tend to become very large. And now it's really becoming a challenge. How can you deliver the information based on your data model? That's the challenge then. And now think about this. If I have this model, what do I want to produce? Typically a star schema where I can, let's say, analyze the line items, where the facts, the line items become the facts. So in this model here, I would just create a fact table, most probably on those two entities. And to be honest, if you model it well, you get rid of the satellite here. I would try to get rid of the satellite by denormalizing attributes that are important for my typical casual user into the dependent child link, like the amounts, the quantities, everything that you want to aggregate or group by. I would denormalize into the link structure. So in reality, I'm only looking at this table here for my fact view, for my fact. And then for my dimensions, well, I need a product dimension, that's sure. And I need some form of a invoice dimension. And that's where I'm starting to struggle a bit. Because now you could think about this. Either you create something like this here, but it gets ugly, right? You have to join 4 entities. But what about the customer dimension, the salesperson dimension, and so on? It gets ugly. It's always 4 entities here, right? So that's a bit where I'm struggling. What about preparing the link, denormalizing the link line item, the line item link a bit more by adding the hub references from the parent invoice also to the link line item, having direct hub let me just use green again, direct hub references to the salesperson and to the customer as well. We can do that because we said in a staging process or later, we can denormalize data. That's all good. We do this typically in the staging process. So that's all good. We can denoise data into the raw data vault. So because then your star schema is relatively straightforward. You have to mess up the colors here. Let me use red. The more colors, the better, right? So you have the fact table here. You have 1 dimension, 2 dimensions, 3 dimensions. And when you move those, when you get rid of this link here, you move those satellites here to the hub. You got 1 dimension for the invoice number. And that's a star schema already. Fact, 4 dimensions, done. And that's about it. So I use these tricks here to deal with high volume of data and to produce the facts quickly. That's the big one here. And now if I go back to the example from the internet, let me just save this. Okay, I hope it's saved. Let me just share again here. So on this one, let's try here to create facts and dimensions. And that's a challenge because, okay, so what is the fact here? The fact is still the line item number, the line items, right? So it's somewhere here. I need this one. I need this one with the amount, not a good practice, because now I need to join the amount satellites in order to aggregate data. But that's a problem. In my previous example, I tried to get rid of that satellite. Why? By denormalizing the attributes into the link structure itself. Because those 2 tables tend to become very large. And if you move them on a column-based storage, which you do typically, the join between 2 large column store-based tables becomes ineffective in Impala, in other database systems, right? So you want to avoid these joins on very large tables on a column-based storage. But this is what I need to do. Yep, those 2 tables. Okay. All right. We need this music for the waiting line. Okay, should be just enough. There you go. All right. So this is my fact table. And then I need, again, my dimensions. What I see is the product. That's easy. So I can join that. There would be also a customer dimension, right? Because there's a customer reference. So I give that this one with a satellite. So this is also easy. Customer product. And then the invoice. Invoice is down here. So to some extent, I tend to agree with this design, to some extent not. Now, let's say I want to produce, and it really depends on, so typically, here's the thing, typically, and I'm getting in a rush here. So typically, I always tell people in the training and also in projects to really focus on modeling the raw data as it is, being used by the business user. So that's a reference to the business keys, right? But focus really on the raw data as it comes from the source. Don't try to overmodel it and so on. Focus on the really model in a data-driven fashion. Except for those tables here, because those tables, again, have high volume. In some cases, those 2 tables here, in telco, for example, those 2 tables for the facts are the reason why you need an MPP cluster, because of so massive volume. The rest, I mean, they don't have many customers, a couple of million customers, handful of products, but billions of rows in here, right? And that's a challenge. That's why you need an MPP cluster in the first place. All right. So what about if I want to produce a fact entity on the invoices? Can I produce that one? Yes, to some extent. The problem with the hub design is, and now I'm essentially coming back to my previous design, right? The problem with the hub design is that for the hub, in order to produce a fact entity now, where I have 1 fact per invoice, I need to join. I need to join from the hub into the satellite. Again, high volume of data. You can't join these tables realistically. So I would tend to create a non-hysterized link for that, as in the book. And just go forward, as in the book. or in my first attempt on the whiteboard here, which I most probably have lost again, I would create a non-hystricized link. Why? Because then I could again denormalize attributes like the amounts from this slide here, the amounts billed and paid and so on. I could denormalize that into the link structure as well. Again, quickly producing the facts based on the invoices. And in this design, wait, and let me just go back to the whiteboard again. Let me just quickly draw it up for you again. Okay. So this design, let's say we have, here's my final design. I would come up with let's start down here, a dependent child link. We call this DL actually, line items that refers to the products, hub product. There's a satellite down here. I have a hub for the invoice number in between that contains, might contain, there will be some satellites that should, maybe don't watch the errors, they all mess up. But this one might contain some header information, especially that header information that I don't need for the aggregation on the invoice level. And then I have a non-hystricized link for the invoice itself. And that includes the amounts. Like I have the totals here and so on. And maybe some satellites containing those attributes which I don't need for any aggregation. Like maybe some additional header information, I would tend to move them down here because the header information I might need for a invoice dimension. That's why I'm struggling here a bit, right? So look at the attributes and look at what attributes are required by the dimension for the invoice and might move them here. Yeah. In the worst case, I might even replicate some data if I need the data both in the dimension, but also in a aggregation level, for example, sometimes. So it really depends. I'm optimizing here everything for speed now, right? To get the facts out of the system in the next step. When I virtualize my information marks on top, right? That's my thinking here at the moment all the time. So, and this one would refer to hub customer, hub salesperson with their satellites. By the way, the arrows should go from hub to satellite like this, and from hub to link like this. So this one is good, this one is wrong, this one is wrong, this one is correct. Okay, so that would be my design, to be honest, because now I can produce, and don't watch the colors, red doesn't mean bad here, right? Now I can produce two fact entities, a fact entity for the invoices on the invoice level, on the granularity of the invoice levels, right? And then I can create a fact entity on the line item level, if desired. I can produce the dimensions. Done. That's my conform dimension if you want. But everything in blue here would be the view on top. That's it. And that's my preferred design for the whole thing. And the reason is really performance, performance, performance. That's the 3 reasons for it. Okay. That's the idea. Now, one last comment. One last comment regarding, and I don't see anything on the chat, which is okay. So one very last comment before we close the session, because I think, yeah, I always stretch the YouTube best format. So one thing for the difference between why do I use here a non-hystricized link and here a dependent child link? That's a big question, right? And that's my personal modeling style, I would say. So in training, we talk about a non-hystricized link having essentially the hub references for the invoice, like in this case, the hub customer, the hub salesperson, and the hub invoice, for example. But then also adding anything that's required to get a unique alternate key. In this case, it might even work because I assume the invoice number is already unique in the enterprise. Let's assume that. The if that's the case, good. If not, you would add the invoice number or some transactional number, whatever. You would add that to the non-hysterized link itself. So the non-hysterized link has a unique alternate key that identifies the transaction, the fact, the message, whatever. That's the idea. And then in the non-hysterized link section in the training, we also discuss denormalizing attributes into the non-hysterized link in order to prevent the join to this satellite down here. I want to prevent that. Because again, the join would be expensive. Again, remember, if I have 1 billion rows in the invoices here, or let's say call records or whatever, I also have at least 1 billion rows in the satellite. Joining those two tables will hurt you. That's a non-hysterized link. And so in the training, we discuss denormalizing attributes into the non-hysterized link, essentially. That's a trick there. For the dependent child link, we discuss it as well, but we focus in the discussion on it in a section. We really focus on having an alternate key again. And we look at the line item number. So this dependent child link would include the line item number to uniquely identify the line item so you can describe it. Because there would be a satellite describing all the attributes of the line item, the quantities, the amounts of the product, and so on. Remember, the product could be on the same invoice on 2 different line items because of different discounts. And you need to capture all this descriptive data from the source system somehow in the raw data vault. That's why you need to have the line item number in the link structure. And no, it makes no sense to have a hub for the line item number because you can't describe the line item number 2 uniquely, because there's so many line item number 2s across the enterprise, right? Even in one single source system. So there's no real need for a hub because there could be no satellite attached to it. All right, so, and here's the thing. In all honesty, for both dependent child links and non-hysterized links, I do denormalize the descriptive attributes because both will lead to facts. And in both cases, if they lead to facts, I want to prevent the join. So in both cases, I would look at the satellite, identify those attributes that I need for aggregation purposes, like the amounts, the quantities, and so on, and denormalize them into the link structure. So what's then the difference? I mean, everything is the same on the dependent child link and on the non-hysterized link. What's the difference? Why do I use the non-hysterized link up there and or call it a non-hysterized link for the invoice and dependent child link for a line item? Quite simple. I use a non-hysterized link when the fact is represented by one row. Let's say a call record or a invoice record, that kind of stuff, or a real-time message. Could be a complex row, let's say a JSON string, like, right? That way of a hierarchy of attributes, but it's one row in a relational world. I use a dependent child link when there's multiple rows coming, essentially representing the bigger fact, let's say the invoice in this case, or when you have a market basket in retail, there's multiple products in the market basket, right? All these amounts, the whole market basket consists of multiple records. That's when I use a dependent child link, essentially, or when I call it a dependent child link, but I use the same concepts in both directions. All the concepts for the dependent child link apply to the non-hysterized link, and for the non-hysterized link, I'd also use the denormalization of descriptive attributes in the concept of the dependent child link, essentially. That's the idea. But that's the difference. When you use this model, you know from now on, at least when you use my models here, essentially our Scalefree models, you know, hey, if there's non-hysterized link, one record represents a fact. If there's a dependent child link, there's multiple records representing the, I don't want to say fact, but the overall fact, essentially. That's the idea. And that's the difference. All right. So this is the model I would recommend. This is what we do essentially in the practice, in the project. Yep. It's all about delivering information. Cool. All right. I hope you enjoyed today. Sorry for overstretching. It's quite unusual, but we missed some sessions, so it was all good. And yeah, if you have a question like this. So, and thanks for uploading the pictures. I didn't create anything except one. That's what we created here. So that's a scan, that's for sure. So, but if you have a question like this, and if you want to upload pictures, maybe just whiteboard stuff, it's all good. Photographs on whiteboard, right? Use this form here, https://sfr.ee/dbfriday. submit your question. Thanks, Michael, for this question today. Good one. And yeah, hope to see you next Friday. Thanks, guys.
Thanks for joining today. If you'd like to discuss this further, give us a call on the number below here, and we're happy to discuss this with you. See you next time. Have a nice weekend. Bye-bye.